The term data communication comprises two words, data and communication. Data can be any text, image, audio, video, and multimedia files. Communication is an act of sending or receiving data. Data communication refers to the exchange of data between two or more network or connected devices. Data can be text, image, audio, video, and multimedia file. Central server, sharing printer connector to switch. The effectiveness of any data communication system depends on characteristics. Delivery: the data should be delivered to the correct destination and correct user. Accuracy: the communication system should deliver the data accurately without introducing any error. The data may get corrupted during transmission, affecting the accuracy of the delivered data. Timeliness: audio and video data has to be delivered in a timely manner without any delay. Such a data delivery is called real-time transmission of data. Jitter is the variation in the packet arrival time. Uneven jitter may affect the timeliness of data being transmitted. A sender is a computer or any device which is incapable of sending data over a network. It can be a computer, mobile phone, smartwatch, walkie-talkie, video record device. Receiver is a computer or any such device that is capable of receiving data from network. Can be computer, printer, laptop. The sender and receiver are known as nodes in the network, NODE. Message is the data or information that needs to be exchanged between the sender and the receiver. Message can be in the form of text, image, audio. Communication media is the path through which the message travels between source and destination. The path through which the message travels between source and destination is also called medium or a link which is either wire or wireless. For example, a television cable, Ethernet cable, satellite link, microwave. For example, a television cable, telephone cable, Ethernet cable, satellite link, microwave. Communication media is the path through which the message travels between source and destination, called medium or link. Transmission: television cable, telephone cable, satellite link, microwave. Protocol is a set of rules to be followed by the communication in order to have successful, reliable data communication, like HTTP. In data communication, the transmission medium is also known as channel. The capacity of a channel is the maximum amount of signals or traffic that a channel can carry. It's measured in terms of bandwidth and data transfer rate as described. The transmission medium is channel. Capacity of channel is maximum amount of signals that a channel can carry, measured in terms of bandwidth and data transfer rate. Bandwidth of a channel is the range of frequencies available for transmission of data through that channel. Higher the bandwidth, higher the data transfer rate. Normally, bandwidth is the difference of maximum and minimum frequency contained in the composite signals. Bandwidth is measured in hertz. 1 kHz equal 1000 Hz, 1 mHz equal 1000 kHz, so 1000 Hz. Bandwidth is measured in hertz. Difference of maximum and minimum frequency contained in the composite signals. Higher the bandwidth, higher the data transfer rate. Range of frequencies available for transmission of data through that channel. The maximum amount of data transmitted over an internet connection in a given bandwidth is the maximum amount of data transmitted over an internet connection in a given amount of time. Bandwidth is often mistaken for internet speed when it's actually the volume of information that can be sent over a connection in a measured amount of time, calculated in megabits per second. Bandwidth is how much information you receive every second, while speed is how fast the information is received or downloaded. Latency is sometimes referred to the delay or ping rate. It's the lag you experience while waiting for something to load. If bandwidth is the amount of information sent per second, latency is the amount of time it takes the information to get from its source to you. Throughput. Bandwidth versus throughput. Throughput is how much information actually gets delivered in a certain amount of time. So if bandwidth is the maximum amount of data, throughput is how much of the data makes it to the destination, taking latency, network speed, packet loss, and other factors into account. How much information actually gets delivered in a certain amount of time. Data travels in the form of signals over a channel. One signal carries one or more bits over the channel. Data transfer rate is the number of bits transmitted between source and destination in 1 second. It's known as bit rate. It's measured in terms of bits per second. The higher units for data transfer rates are 1 kbps equal to 10 bps equal 1024 bps. 1 mbps equal to 220 bps equal 1024 kbps. 1 gbps equal to 230 bps equal 1024 mbps. 1 tbps equal to 40 bps equal 1024 gbps. Mbps stands for megabyte per second, whereas mbps stands for megabit per second. Megabyte per second. Mbp, where the B is the capital letter. Data transfer rate tells you how quickly data is moving, not how much data you can move. It depends how quickly data is moving, not how much data you can move. That's how much data you can move is bandwidth. How quickly data is moving is data transfer rate. It depends on bandwidth, network traffic distance, quality of connection, and hardware limitation. Bit rate is the speed at which one device sends data to another, usually in bits per second. Bit rate is the speed at which one device sends data to another, usually in bits per second or bps. These are the most basic unit of information for electronics. In data communication, one computer digitally transfers a string of binary number of bits, and then the receiving device translates them into code. The faster device sends bits, the higher the bit rate. Faster device sends bit, the higher the bit rate. The speed at which one device sends data to another, usually in bits per second. Bit rate is the speed at which one device sends data to another. Bit rate is the speed at which one device sends their data to another. You can use a bit rate to describe file download and upload speed, audio quality, internet speed, other metrics related to communication. You can use a highway analog, bandwidth equal number of lanes, bit rate equal how fast each car is driving, data transfer rate equals numbers of cars that actually reach their destination per second. Bit rate is the speed at which one device sends data to another, usually in bits per second. Transfer a string of bit. One computer digitally transfers string of binary numbers, and then the receiving device translates them into a code. Band rate or symbol rate is the number of signal changes that occur in 1 second, and it directly influences how quickly your device can transmit data. Baud rate or symbol rate is the number of signal changes that occur in 1 second, and directly influences how quickly your device can transmit data. When sending data electronically, one device sends electrical pulses that contain information to another device. When sending data electronically, one device sends electrical pulses that contain information to another device. The baud rate is the rate at which those pulses travel between devices, and you can measure baud rates in pulses per second or symbols per second. Each pulse communicates a limited amount of data, so system with a higher baud rate can transmit information faster than system with a lower baud rate. Calculating these two metrics involves using different equations. The software and hardware of a modem or computer determine the bit and baud rates. Factors that determine a device baud capacity and bitrate are its physical structure, wiring code, and device memory. Bitrate equal number of bits each part can transport multiplied the baud rate. Baud rate equal bit rate divided the number of bits per pulse. Number of bits each part can transport times baud rate bitrate divide the number of bits per pulse. You use bitrate to discuss how efficiently your system transmits data, while you use baud rate to discuss how the system moves the information. Bitrate how efficiently your system transfers data, baud rate how the system moves the information. Bitrate is more important for individual devices because it concerns data transfer speed. Baud rate is more appropriate when describing the data transfer capacity of entire computer networks. Baud and bitrate are significant when interpreting the speed of data networking between devices. A high baud rate typically means your system can process more information from multiple users, while a high bitrate means that the system can process that information more quickly. System can process more information from multiple users. Bitrate is number of bits transmitted per second. BPS, kbps, and BPS. All you need are bitrate bandwidth and data transfer rate are BPS, kbps, and BPS. Bitrate speed of sending digital bits, bandwidth, maximum data, maximum capacity of data that can be transmitted, data transfer rate, amount of data successfully transferable network, actual speed of data, baud rate, number of signal changes, pulse per second signal. In a network having multiple devices, we are interested to know how to connect the sender and receiver so that one-to-one communication is possible. One solution is to make a dedicated connection between part of device mesh topology or between a central device and every other device, a star topology. However, such methods are costly in case of large networks. An alternative to this is switching whereby data is routed through various nodes in the network. The switching process forms a temporary route for the data to be transmitted. Two commonly used switching techniques are circuit switching and packet switching. In circuit switching, before communication starts, a dedicated path is identified between the sender and the receiver. This path is connected a sequence of links between network nodes. All packets follow the same path established during the connection. In earlier days, when we place a telephone cord, the switching equipment within the telephone system finds out a physical path or channel all the way from our telephone network to the receiver telephone. This is an example of circuit switching. In packet switching, each information or message to be transmitted between sender and receiver is broken down into smaller pieces called packets. These packets are then transmitted independently through the network. Different packets of the same message may take different routes depending on availability. Each packet has two parts: a header containing the address of the destination and other information, and the main message part. When all the packets reach the destination, they are assembled and the complete message is received by the receiver. Unlike circuit switching, a channel is occupied in the packet switching only during the transmission of the packet. On completion of the transmission, the channel is available for transfer of packets from other communicating parties. Circuit switching requires connection setup, fixed resource usage, resolve less efficient telephone networks. Packet switching is not require connection setup, packets routed independently, share resource usage dynamic, highly efficient, and internet emails WhatsApp. Circuit switching is require connection setup, fixed resource, less efficient telephone networks. In data communication, transmission media are the links that carry messages between two or more communicator devices. Transmission can be classified as guided or unguided. In guided transmission, there is a physical link made of wire cable through which data in terms of signals are propagated between the nodes. These are usually metallic cable, fiber optic cable, etc. They are known as wire cable. In unguided transmission, data travels in terms of electromagnetic wave using an antenna. They are also known as wireless media. Communication media, wire media, wireless media, electromagnetic wave, wire media, twisted pair cable, coaxial cable, fiber optic cable, electric signals, wireless media, radio wave, microwave, infrared. Any physical link that can carry data in the form of signals belongs to the category of wire transmission media. Three commonly used wire media for data transmission are twisted pair, coaxial pair, and fiber optic pair. Twisted pair and coaxial cable carry the electric signals, whereas the optical fiber cable carries the light signal. A twisted pair consists of two copper wires twisted like DNA helical structure. Both the copper wires were insulated with plastic cover. Usually, a number of such pairs are combined together and coupled with a protective outer wrapping as shown below. Each of the twisted paths acts as a single communication link. The use of twisted configuration minimizes the effect of electrical interference from similar paths close by. Twisted paths are less expensive and most commonly used in telephone lines and LAN. These cables contain of two types: unshielded twisted paths and shielded twisted paths. Crochet cable is another type. Both the coils are insulated with plastic cover. Crochet cable is another type of data transmission reader. Is better shielded and has more bandwidth than a twisted path. These types of cable are used to carry signals of higher frequency to a longer distance. It has a copper wire. The core of the cable is surrounded with insulating material. The insulator is further surrounded with an outer conductor, usually a copper mesh. This outer conductor is wound in plastic cover. The key to success of core and shark cable is its shielded design that allows the cable core to transmit data quickly without interference of environmental factor. The optical fiber carries data as a light which travels inside a thin fiber of glass. Optic fiber uses refraction to direct the light through the media. A thin transparent strand of glass at the center is covered with a layer of less dense glass called cladding. This whole arrangement is covered with an outer jacket made of PVC or Teflon. Such types of cable are usually used in backbone networks. These cables are lightweight and have higher bandwidth, which means higher data transfer rate. Signals can travel longer distance. Electromagnetic noise cannot affect the cable. However, optic fibers are expensive and unidirectional. In wireless communication technology, information travels in the form of electromagnetic signals through air. Electromagnetic spectral frequency ranging from 3 Hz to 900 Hz is available for wireless communication. The electromagnetic spectrum range 3 kHz to 90 THz can be divided into 4 categories: radio wave, microwave, infrared, and visible light wave according to their frequency ranges. Bluetooth is a short-range wireless technology that can be used to connect mobile phones, mouse, headphones, keyboards, computers, etc. wirelessly over a short distance. All these Bluetooth-enabled devices have a low-cost transceiver chip. This chip uses the unlicensed frequency band of 2.4 GHz to transmit and receive data. This device can send data within a range of 10 meters or a speed of 1 to 2 Mbps. In Bluetooth technology, the communication device within a range of 10 meters build a personal area network called PiCoreNet. The device in the PiCoreNet network in a master-slave configuration. A master device can communicate with up to 7 active slave devices at the same time. Bluetooth technology allows up to 255 devices to build a network. Out of them, 8 devices can communicate at the same time, and remaining devices can be inactive, waiting for a response command from the master device. All these Bluetooth-enabled devices have a low-cost transport chip. This chip uses unlicensed frequency band for 2.4 GHz to transmit and receive data. It can send data within a range of 10 meters with a speed of 1 to 2 Mbps. Wireless LANs. This network consists of communicating devices like laptops and mobile phones, as well as the network device called APs, which is installed in buildings afar. Wi-Fi gives users the flexibility to move around within the network area while being connected to the network. Wireless connection can be used to extend or replace an existing wire infrastructure, resulting in increased access for mobile devices. Provides easier access to the internet in public places and represent existing wire infrastructure. A modem is a type of network device that modulates and demodulates analog carrier signals to encode and decode digital information for processing. It transmits data by modulating carrier wave signals to encode the digital information. The receiver will demodulate the digital signal for recreating the original digital information. It transmits data by modulating carrier wave signals to encode the digital information. The receiver will demodulate the digital signal for recreating the original digital information. Demodulate the digital signal for recreating original digital information. Cable modems. Cable modems is how we establish communication between computer and ISP over landline connection. These modems allow the access to high-speed data with the help of a cable TV network. Such modems are Ethernet device connected to a PC with the help of a standard 10-base Ethernet card and twisted pair wiring. Telephone modems. These modems are network devices that allow data communication between two computers over voice-graded telephone lines. Telephone modems convert bits to analog signals for transmission through physical channels. They are also convert the analog signals in the local loops into bits that are understandable by a computer. Dial modems. These modems convert the data between analog form and digital form. This networking device prior to copy the at one end and the telephone and another. These modems can transmit data at a maximum rate of 56,000 bits per second. Satellite modem. These modems provide an internet connection with the help of satellite dishes to transfer input bits into output reduced data and secures the vice versa. These modems are more reliable for providing internet network in comparison with other modems. Digital subscriber lines are used for transmission of the digital data over telephone line. These modems offer high-speed internet connection through telephone line. Two types of DSL modem include asymmetric and symmetric DSL that use existing telephone wiring within your home wiring. Due to the use of existing wiring, these modems are cost-effective. These are transmission of the digital data over telephone line.